Hello and welcome to KX Insiders, our new monthly show that puts you, the developers, front and center for all things KX. I'm Daniel Baker, Head of Evangelism, and in this episode we're going to be discussing the several world records that we've achieved by using the STAC benchmarking tools. STAC, the industry standard for testing solutions that enable high-speed analytics on time series data, have once again confirmed that KX continues to dominate the space, increasing our previous speeds in some instances twofold. In fact, KDB Plus, the database that powers our products, provided the fastest execution in 93% of STAC M3 queries, highlighting our unprecedented speed and scalability for the most demanding real-time analytics. It's an incredible achievement and demonstrates why we have become the go-to technology across industries where time series data is used. To help me understand more, I'm delighted to be joined today by our panel of experts, Dr. Ferenc Boden, Head of Benchmarking at KX, and Peter Nabicht from STAC Research. Gentlemen, welcome. So Peter, let me start with you. Firstly, thank you so much for joining us today and helping our viewers understand the STAC audit process. Could I perhaps ask you to begin with a brief overview of the STAC Council and its members?
Sure. So the Securities Technology Analysis Center, or STAC, improves technology discovery and assessment through rigorous research and industry dialogue. The STAC Benchmark Council is made up of financial firms such as exchanges, the world's largest banks, proprietary trading firms, and hedge funds, as well as leading technology vendors. Together, the council creates and maintains benchmark standards for big data, big compute, and low latency workloads. Technology users and vendors work together to create STAC benchmarks, but in the end, user firms have the final say. This ensures that benchmarks focus on real business needs and represent workloads and operations that user firms deal with on a daily basis. The council also gathers at large STAC summits and in small groups to discuss key technical challenges and solutions.
Thanks, Peter. So you mentioned that both vendors and technology users work together to benchmark systems, but what happens to these results? Are they then made public?
If a vendor wants to make STAC benchmark results public, they can engage STAC to perform an independent third-party audit. In an audit, STAC conducts the test going to great lengths to ensure that all the benchmark specifications are followed exactly. Furthermore, we dive into the technology stacks and document their configurations in great detail. The audit process and the resulting STAC reports, configuration disclosures, and other documentation ensures that each audit is repeatable, fair, and comparable to other tested systems. What do we mean by this? Well, repeatable means that a STAC subscriber with access to STAC tools should be able to obtain similar results if they test the same stack. Fair means a level playing field. There's no way for a vendor to put their thumb on the scale or keep running tests until they find results they want to cherry pick for disclosure. And comparable means that people can make apples to apples comparisons of multiple solution stacks, whether those stacks differ entirely or only at one layer.
Peter, that's great. I love the transparency of the testing process and how STAC ensures the results are regulated. But could you perhaps explain in a little more detail what the tests cover in terms of component performance?
Yeah, we have multiple benchmarks, but we'll stay focused on time series analytics. The STAC M3 benchmark suite is the industry standard for testing solutions for high-speed analytics on time series data in finance, such as tick-by-tick quotes and trades. These analytics are critical for everything from algorithm development to analyzing real-time trade results to risk management. Capital markets firms have relied on STAC M3 to give them insight into the performance of new products and their own in-house tech stacks for over a decade. The specifications are agnostic to architecture, so STAC M3 is used to compare different products or versions of those products at any layer of the stack, from database management systems to processors to memory to storage. This holds true for both on-prem and cloud solutions. STAC M3 has 4 separate benchmark suites, so it covers many needs for both live and historical market data analysis. Antuco is the baseline suite. It has a broad range of read and write operations. The data set is relatively small, but it forces queries to read from non-volatile memory. Shasta is the same as Antuco, except it allows queries to read from memory. Kanaga is the scaling suite. It studies a few operations, but on large data sets and large numbers of concurrent requests. And finally, we have Jalua. It adds streaming data to the mix. Jalua studies the ingest capacity of a system, including how long it takes for ingested data to become available for querying, as well as query response times for both live and historical data.
Thanks, Peter. I really appreciate you taking the time to join us today and explain the STAC benchmarking process. And while I appreciate that these tests are optimized for financial markets, I can also see how they could easily be applied to other industry verticals, especially now that companies are realizing the competitive advantages of real-time ingestion, processing, and visualization. So let me turn to you, Ferenc. Firstly, congratulations on the results. As our head of benchmarking, you must be thrilled by the performance gains achieved, and I'm sure that you're probably already looking into ways that these gains can be further tweaked, optimized, and enhanced. Now, I know that in this instance, we work with Intel. So could you perhaps help our audience understand why it's important for both hardware and software vendors to work together in relation to these benchmarks?
So our partnership with Intel extends several years, and together we've continued to innovate the ways in which our technologies complement each other. Let's look at KDB, for example. By leveraging the instruction set extension of the Intel CPUs, we've been able to tweak the execution of our vector programming tools and ensure that our end user achieve the best possible throughput. When paired this with high capacity memory of the Optane, clients can nowadays store their most demanding data in the closest proximity to CPU, connected to it by the most powerful data bus. Similarly, using the Optane as a regular high-speed disk, the response time of the historical queries are slashed. What's more, with App Direct mode, the developers can now decide how they distribute the data between DRAM and Optane. They can even decide to split the columns of a table based on usage frequency.
Ferenc, that's great. Now I know that during STAC benchmarking we were able to break several world records. Could you possibly share these results with our viewers?
Sure. So during the summer, Intel and KX participated in the On2Co suite of tests. The 7 multivariant queries adding up to 17 read-write tests of different characteristics were performed over 4.5 terabytes of data. This STAC M3 benchmark is considered to be the most comprehensive time series benchmark on the market for mid-size data. Our two-server setup incorporating Intel's latest generation of the Optane disk outperformed all publicly disclosed results in 10 out of the 17 tests. This also demonstrated a speed improvement exceeding 2.4 times compared to the previous world records. We also participated in the Kanaga tests, with Dell allocating 10 servers, each having 2 previous generation Optane disks. The results were phenomenal. We broke 16 previous world records and measured a 60-fold improvement over the previous best results.
60 times faster? That's incredible. I mean, I knew we were fast, but that's something else, Ferenc. But tell me, in order to achieve these outstanding results, did we need to make modifications to our code?
So the KDB scripts were written several years ago and were optimized for the hardware of the time. Since then, we have seen massive increase in both disk performance and in CPU core count. Nowadays, it is not uncommon for large data estates to work across hundreds of cores. Vendors are continually working on ways to improve the parallelism and ways in which they can reduce latency. Also, the focus shifted from waiting for I/O because Optane upped the game. This meant that we could refactor our scripts to take advantage of the reduced latency offered by this technology.
Okay, but if I put my IT administrator hat on for a moment, there are always bottlenecks to any process. What did we do to identify and resolve these?
Yes, every system has a bottleneck, so I reviewed every single query and ensured that they were fully optimized across all core components. Each query stresses a different part of the system, so there was no golden rule on how to improve the speed. The work resulted in efficient parallelization and even task distribution that ensured there was no unnecessary contention of system resources. Furthermore, we also introduced some new techniques that were not available in the language in 2010. Examples are multi-threaded primitives, and socket sharding that uses the Linux kernel to load balance and distribute subqueries across individual KDB processes.
Ferenc, thank you so much for helping me understand. So to wrap this up, we hold 14 of the 17 Antico world records. And if we calculate the mean response rate for each query in comparison to our closest competitor, we're over 4 times faster across the breadth of the tests. What's more, the Kanaga test proved that KDB Plus is the fastest across all 24 queries, meaning that when speed is of a paramount importance, KX should be top of mind. In closing, I want to remind our viewers that no matter the industry, analysts share a common goal: to be able to access information immediately and remove the delays that fragment workloads and slow decision pipelines. At KX, our analytic solutions have helped organizations ingest, process, analyze and deliver massive amounts of real-time and historic data for over 25 years, including workloads such as anomaly detection, predictive maintenance, automation, and financial markets. In fact, in our publication, 5 Steps to the Microsecond Mindset, we openly discuss an end-to-end process of how companies of all sizes are leveraging real-time data and using it as a catalyst for disruptive innovation. If you would like to find out more and dive deeper on our incredible benchmarking results, then we have several resources available from the URL on screen. And don't forget, you can carry on the conversation at any time at community.kx.com. Thank you.